Hey guys, welcome back. We've been working on limits for a few days now. We have looked at it graphically and algebraically. We have been performing some limit rules or some limit properties without even thinking about it. So what I mean by that is this. So I'm going to use this example here, and if we were typically going to do this in class, you would just say, all right, the limit as x approaches 1 of 2x squared plus 4x minus 1, I would just plug in the 1, and I would just get 2 times 1 squared plus 4 times 1 minus 1, and I would get 2 plus 4 minus 1 is 5, and so the limit as x approaches 1 of this function is equal to 5. Now, we know that we never plug in the actual 1. We plug in numbers really, really close. It's approaching 5. Great. But what we've actually done here is we did a lot of the limit properties. So what I mean by that is this. I can look at this in pieces. So 2x squared, limit as x approaches 1 of 4x, the limit as x approaches 1 of negative 1. I can look at them as functions, like 2x squared by itself, 4x by itself, negative 1 by itself. Remember, negative 1 is just a horizontal line, right? So what we can do here is we can say, all right, this is the same thing as actually saying 2 times the limit as x approaches 1 of x squared. I know it's insane to break it all up, and why would we do it? It's actually really important. So 2 times 1 squared, that's 2. In this case, we would go 4 times 1. So 2 and 4 are what we call constants, okay? So that's 4 times 1 is 4, and then a negative 1. Remember, this is just a line at negative 1, and the limit as x approaches 1 will be negative 1. And then what we did there was we took 2, and then we added it, we summed it with 4, and then we subtracted it, or we took the difference, and we get the same number here. And so I just wanted to show you guys the properties. In general, if the limit as x approaches a of some function goes off to m, and the limit as x approaches a of some function goes to n, then we can do a few things. Now think of function f of x and g of x just like this, 2x squared and 4x. That's all that is. So just think of it like that. Well, what did we do with this? We took the 2 and we added it with the 4. So what they're saying is the limit as x approaches a of a function basically could get split up, okay? And then we sum them together, and we would get m plus n. That's all we're doing there. We can also take the difference of the two, and then we would get m minus n. You can separate them. This is that constant k I was referring to over here with 4 and 2. Well, the limit as x approaches a of f of x is m. So this is k times m. This is a product. So all you're going to do is m times n. Quotient, m divided by n. Okay? This is the power. I did it here. X squared. Same exact thing. This is m to the n. And this is the root. Okay? I don't know why I did that, but I'm going to do that. And you know, typically teachers show it in the beginning. I like to show it at the end. I didn't want to miss this lesson. So let's just do really quickly a few examples, and then we're done with this. I give you guys 4 functions, f of x, h of x, g of x, and k of x. One of them is the square root. One of them is the power. One of them is just a little x plus 2. This is 5x. Well, what is the limit as x approaches 8 of f of x? I don't even know why I chose that, but that's okay. Square root of 8. What's the limit as x approaches 3 of g of x? That's going to be 9. What's the limit as x approaches 5 of h of x? 7. What's the limit as x approaches 6 of k of x? 30. And that's all. I hope everybody enjoyed it. I feel really badly if I did not make this video. There's some properties, and one of them that you might really want to know for later on is the quotient when we go into L'Hopital's rule.